So the session today is called From Zero to Multi-Cloud Hero in 60 Minutes. It sounds ambitious, and it is. We're going to deploy a complete multi-cloud setup in the time that we have the session. We're doing a real demo with a real hardware infrastructure based in Berlin, which is where I live. You're probably thinking that guy doesn't sound German. I'm from the UK, and I moved to Germany about 10 years ago. I'm a senior architect in CX, so our services arm doing consulting with customers. And yeah, I used to work for VMware, used to work for Dell, have a background in server infrastructure, virtualization, and today focused on cloud, Kubernetes, and automation. Pedro, would you like to introduce yourself?
Yeah, hello everyone, Pedro Antunes. I am based in Poland, but I don't, like Matt doesn't sound as a German, I don't sound as a Polish, I'm from Spain. And I have been focused, I have software consulting engineer in CX, but I am mostly focused on DevOps stuff and platform engineering.
So, the agenda for today, why multi-cloud might be the first question. Why are we doing what we're doing? It might sound fun, it might be fun to do in a lab, but there are real reasons why we're doing this. Pedro and I are not in sales, we're not product sellers, we're not here to sell a product, we're here to give customer experience. So building real architectures with customers, consulting them over many years sometimes to realize transformational journeys into multi-cloud. So this is what we want to show. Then we'll go into actually what we're going to show, what we're going to demo today. So we have a demo for you. We're going to show a complete demo end-to-end, and then we're going to break this down into sections and show you exactly what's happening here. We're going to then talk about a typical developer story. So in this case, Pedro is going to take over and be our developer and walk us through how the process for deploying apps might look in certain organizations and how things can maybe develop in the future using automation. We're going to then show how we can operate a multi-cloud with infrastructure as code. So then we dive a bit deeper into Git, Ansible, Terraform, all this good stuff, pipelines, and show you actually how we build this, what's the technology behind this. Then we're going to bring our cloud environments together. So we're going to use something called Cilium. Who here has heard of Cilium? There's some hands. There's a lot of excitement here as well. We've got a lot of questions on our first session on Monday. We're not going to have a deep dive in Cilium today, but we're going to show you some really cool functionality around it. And maybe just a quick call out here, this is not a deep dive session into any particular technology here. We cover SD-WAN, ACI, VMware, virtual machines, Kubernetes, applications, observability, Cisco Workflows, which is an excellent new workflows tool Cisco have. Anything I've missed?
And an application on top.
And an application on top, a microservice application. So we've hit all the buzzword bingo there.
Not ambitious at all.
Anyway, so it is ambitious. So first of all, why multi-cloud? Why are we doing what we're doing? We all know that the landscape is getting more complex. We have lots of various cloud environments. Now we have lots of LLMs running in SaaS, and we also have some security concerns around these LLMs. But the pace of development is unyielding. We need to make sure our developers can build applications and have access to all the infrastructure and services they need, while securing that data, making sure that we're fulfilling requirements like compliancy, regulation, sovereignty is a big one I'm hearing a lot about nowadays, especially here in Europe. So what is a multi-cloud? I don't think this is going to be much of a surprise. We would have a Cisco, well, hopefully Cisco data center on the left, as seeing as Cisco Live. We would have various hyperscalers, potentially AWS, Google, Azure, Alibaba, take your pick. And we have the internet in the middle, connecting them all together. And why do we use it? So we typically see various use cases. One customer I'm working with at the moment says they want to do all their development in the cloud. So they want to set up a cloud environment. They want to give their third-party developers access, and those developers can then build containers and then ship those into on-premise environments, which would be sovereign or regulated, so air-gapped potentially, or very high security requirements. So we want to develop in the cloud and then push gradually into more secured environments. Other use cases might be, we have marketplace SaaS products. We might have a great AI tool from AWS that we want to use and integrate with our data. So this wouldn't be a Cisco Live or conference session today without talking about AI. These are the only 2-3 slides on AI, and then we're going to move forward. Other reasons that we're genuinely seeing from customers is they're saying, okay, we have a lot of data on premise. We have huge storage arrays. We've been told by Dell or EMC, the company I used to work for, just store it, get the data collected, and then we'll find out something to do with it later, potentially. So we have a lot of inference that needs to be done on that data. But the training might be happening in the cloud. So we might need a big GPU cluster. Maybe we can't get that in time. Maybe it's very expensive. Maybe the supply chain delays are taking a while. So in the end, we need someone to train our data. And of course, our generic AI SaaS product we have on top, which might be released, that we want to integrate into the setup. But typically, this is the kind of reasons, right? Regulatory, compliant, sensitive data on-premise is what we're seeing. Training, development, elasticity in the cloud. There's a couple of, let's say more kind of Gartner, marketing slides here. This isn't a marketing session, but I want to maybe get a couple of points across. There is a big move through repatriation, specifically in relation to AI, because of that previously mentioned point of data gravity. There's just a lot of data on premise. And sovereignty. So I work particularly with the public sector. They're very concerned potentially about having disagreements with other governments, and the other governments turning off the tap and not letting them have access to the latest and greatest AI models. And this brings me to the next point. So Cisco, and particularly in Cisco Germany, and particularly myself, work in a body called GovTech. And GovTech are developing standards for the integration of the public sector into public cloud environments. So we were working with the state governments, the Federal Employment Agency, the pension agency, healthcare companies, the private sector, so Cisco obviously, European superscalers, the big 3 hyperscalers, and also the regulators. So we're working with the BRC, the Bundessicherheits, Information Federal Security Office, and the Data Protection and Freedom of Information Commission, which has a lovely German name, which is about this long. So I won't try and say it in this session, otherwise it might take the rest of the time. But basically what we want to do here is show that we have on-premise environments. There's a need for these to exist in the future, but we need to also integrate the best that we have in the public cloud to make a model where basically citizens can get their services up and running faster. Germany has a big problem, as many of you probably know, with paperwork, bureaucracy, and slow government. So we're trying to maybe see what we can do here with technology to speed some things up. So that's the introduction. What are we going to show today? We are going to show this application here, which is a multi-cloud hosted application in Google and on-premise. You can see that one of our friends and co-presenters has shamelessly put his book into the store. It doesn't actually cost $16.79. It is free, and he's doing a signing, I believe, tomorrow at the iSolve Cillian booth, so you can get a copy there. Anyway, we have a multi-cloud hosted application that we want to show, which would look a bit something like this. We have Cisco data center infrastructure on the left, based in Berlin, which is where I live. I rack this, I stack this, I put this in the rack, I set up the UCS servers, I deployed VMware, set up ACI, and we fully automate this environment. So everything in the environment is driven by automation now. There's no manual actions. And then we have a Google Cloud infrastructure. So Cisco provide a multi-cloud service where we can set up accounts, and we have an account here which we connect back to our Cisco data center in Berlin. So what do we do in the demo today? First of all, we provide the WAN connectivity. This is actually done already. We use SD-WAN here, but in the end, you could do a VPN, direct connect, whatever. We just need a connection between the 2 sites for our private networks. We deploy ACI. We do this with ACI as code, which is an infrastructure as code automation tool for ACI. There's lots of talks here about it. We're not going to go in deep, but we'll show you something about it. We're going to deploy a Kubernetes cluster. Maybe just a quick show of hands. Who is using ACI? just to get a feel for the room. Yeah, good amount of you. Who is familiar with Kubernetes? Yeah, I think probably everyone by now, right? I mean, when I said that a few years ago, it was a different selection of hands, but I think it's become a lot more popular, right? And everyone's seeing this in organizations. So we do that in the cloud as well. We deploy Google Kubernetes engine with Cilium. We do what's called a cluster mesh, which is where we take these two clusters and we bring them together. So they can be operated logically as a single cluster. We can do some fun things like active scenarios, active standby, failover, all kinds of good stuff. And then we will observe the application on top. So we have our multi-cloud application distributed in Berlin, in the cloud. The cloud location is connected, the clusters are meshed, and we can observe this. So with that being said, we better get started on the demo. So what Pedro is going to show us now is something called Cisco Workflows. I'm just going to run through the workflow quickly, and then Pedro is going to bring the demo up on the screen. First of all, we're going to deploy SD-WAN. This is pre-deployed, as we said, takes about 45 minutes, so we wouldn't get things done in time. We're going to configure ACI, automated. We're going to deploy on-premise Kubernetes. We're going to install Cilium on this Kubernetes cluster. We're going to do the same in the cloud. We're going to configure the Google networking of VPC. We're going to deploy Google Kubernetes. We're going to install Cilium on top. We're going to do the famous mesh, and then we're going to deploy our application. So, Pedro, would you be able to bring up workflows on the screen?
Okay, so there you have it. Do you want to go through it, or should I?
Yeah, you go through it. What have we got?
So, I mean, this is the complete workflow. I'm pretty sure you're not seeing much, but I'm going to zoom in. But basically, this is what Matt just showed us, right? We are combining these Lego blocks, let's say, that abstract what's happening within. We start configuring ACI. Later on, we deploy our on-prem cluster. After that, we go to Google. We deploy. I mean, we are using Google as an example here. It could be any cloud, any public cloud. We deploy our Google cluster. After that, we can mesh them. And finally, we can deploy our application, right? This is the editor that I wanted to show you so you can see what's happening in between, and that you get the idea that we could rearrange these blocks to have other workflows if needed. And that's the idea, actually. If we go to the end user interface, we're going to trigger this. So I go here, end-to-end workflows demo, run. I'm going to get a very simple form where I am being asked only the necessary inputs to run this flow. So how should we call this, Matt? This is the ACI tenant that is going to be deployed for the on-prem cluster.
This is the Cisco Data Center Networking. Of course, Cisco Live. I think it's probably a good name.
Yeah, makes sense. So Cisco Live. I think we can keep this simple. Let's call it Berlin, because this is actually happening in Berlin, as you said before.
I'm fine with that. I'm fine with that. I'm always happy to represent Berlin.
To keep things simple, Google. So we have all we need. I'm going to trigger this. And in a second, yeah, this is actually happening live. Like, we are configuring ACI. This is going to be, the entire flow is going to be like around 40 minutes. So I'm going to hand it over to Matt again. But this will be happening in the background. We will come back during the session.
Could we show one that's a previous run quickly? Could we show a last successful run?
Of course. If we go here to run monitoring, and I look for, for example, this is how it's going to look like at the end of the session. Basically, everything is happening in order. We have the feedback about the timing of everything. And as I told you, the entire thing is about 37, 40 minutes.
Perfect. Thank you very much, Pedro. So hopefully that's a bit clearer what we're going to do today.
Let's go back to the slides. One sec.
So you're probably maybe asking yourself, what is Cisco Workflows? Again, not a deep dive. There's some really good stuff in the world of solutions. If you want to go and find out more, there's a great team there running a booth. They can tell you more about how to get access, what kind of stuff you can do in it. But basically, it's the new multi-domain automation service from Cisco. It's free if you have Cisco products, licenses, I believe. There's an advantage tier where we can do a bit more complex stuff. We can do more complex workflows in here. The URL is here, workflows.networking.cisco.com. And the really cool thing that Pedro showed us is we have these Lego blocks, right? We can deploy network, deploy Kubernetes, deploy Google Kubernetes, deploy the cloud. And we can take those Lego blocks and we can build them into a Millennium Falcon, which is what we're trying to do today. And the great thing about workflows is we can connect users northbound, like Pedro just showed. He was the user deploying the multi-cloud setup, or we can connect this southbound. So we can do integrations with our infrastructure. It has pre-built workflows with tooling like Meraki, Catalyst Center, ACI. But we can also create generic services, anything else we want. It has the ability to call any API with REST, GraphQL, whatever we need. So, multi-cloud operations. Let's dive a bit more into how we typically see customers run multi-cloud environments or not run them while we run the demo. So a bit of an animation problem here, but I'm just going to bring up the whole slide. So I'm a consultant. I typically go into customers and try and figure out what their processes are for deploying environments. And it's probably going to be no surprise to anyone that we're doing a lot of stuff by email. One customer said, yeah, I send an email, multicast, no one replies. I hope they get it. Telling them that I've done my part of the job. The classic Excel spreadsheet with 100 fields that you can send to someone to fill out. The ticketing system, which is always fun. A customer recently said, developers write their requests in free text, so no drop-downs, no structuring, no standardization. They just write in free text what they want. I mean, maybe that's a good case for a large language model. They can interpret that free text and put it into a request. But we don't have that at the moment. They just have to try and work out what they want. And this really is a problem in multi-cloud because the more stuff that we're doing manually, the more stuff that we're not doing in a standardized way, the more inconsistencies we have, which leads to more difficult troubleshooting, and which leads to very slow updates. People are very scared of updating things because the system is so fragile. They're worried that if they do update something, something's going to break, and then it's going to take a war room. All the teams have to come in, and we have to sit down and figure out what's going on. So every update takes every team to be involved, and then gets pushed back by months or years because, we can't stop the business running. So a typical multi-cloud setup might be something like this. We have our data center in Berlin. We have our public cloud. The workflows between the teams on-premise are pretty unclear. I have my automation, you have yours. Mine runs on my laptop, yours runs on Ansible automation platform or Terraform, or maybe you have GitLab. There's probably not any integration between the modules. I run mine first, you run yours second, he runs his third. The cloud, everything's looking much better. It's easy to automate, and typically the legacy applications are running on-premise. The modern applications, which are easier to operate and observe, are running cloud-native environments in the cloud. And there's not really much integration between the two. So we're not really, we have maybe a direct connect, we have connection, but we're not having much workload mobility. So what are our goals in Cisco? So let me go back, because there's a bit of a missync between, the screen here and up there. So goal one, makes data centers easier to automate. So this is what we're doing. We're doing ACI, automation, UCS, VMware, Nutanix, Kubernetes, but bring this together and do cross-domain automation to bring up cloud platforms. Number two, be the bridge. This was the Cisco motto for many years, but we want to bring these multi-cloud environments together with things like SD-WAN, with things like Cilium. And number three, operate or run and observe your multi-cloud applications anywhere. So have the ability to move your workloads left and right. Our users shouldn't care where the workload is because everything is so easy, seamless, and automated. So to realize this, many customers are building something called a platform team. This is basically looking to, first of all, provide a bringing together of disaggregated services. So the typical example is many customers have AWS, Google, Azure on-premise, and they need to find some way to automate these services in a synchronized way. The platform team should be working with the infrastructure experts, so the ACI experts should be providing guidance on the best way to configure ACI. They should be working with your teams to automate this, and we should be providing this ideally as a service. So the real goal of this is to reduce the drift between silos, so we have a coordinated way of approaching things. There's a platform engineering slide here. If any of you like the idea and want to show your managers, or you are a manager, here it is. I'm not going to go through it. It'll be in the deck, but there's some kind of KPIs, some studies around the adoption that we're seeing in customers. So, over to you, Pedro, for a typical developer story.
So yeah, we have been talking about developers, application, infrastructure teams. Let me put some color and some faces to all of this, right? A typical story that we have seen at home between us, and also we have been told this by many customers, like, let's say this person is our typical developer. That could be me any given day, fighting with Matt, or the other way around, depending on the day. And again, I want to deploy my application. I want it to be highly available, as fast as possible, as simple as possible. Don't ask me questions, just please help me. This application is exactly the same we showed at the beginning, right? Or could be anything, but this is our example. And in general, I couldn't care less about the infra requirements. Again, I just want my application. Obviously, I'm willing to help the team, but I'm just gonna go to the shop, buy the thing I need, and be out of there as soon as possible. On the other hand, we have our infra guy, network team, compute team, a combination of that, depending on the organization, obviously. And he needs to know, okay, you want to deploy an application, but mate, network requirements, where to put it, firewall, what is Kubernetes? Please give me something here, right? Again, we are talking about the typical application, front-end, app, DB. This is for our developer. This guy is more worried about VMs, networks, Kubernetes, firewall. Yeah, give me something. And normally he's going to be complaining, you're not giving me requirements, or you're not giving me any clarity at all. So the conversation is normally something like this, right? I don't know if this sounds familiar to any of you, but again, it's like, hey, I want my app, give me a Kubernetes cluster, please. Can you get the network ready? Okay, any more details? Nope, and how long till we get this running? This is not working at all. The main point for us here is like to try to fix this or help as much as possible. This link is completely broken normally, or these people could be happier at least, which is the goal. And this is where our platform allies, our platform team is coming to the rescue to pacify a bit between them, to help them working together, defining services, abstracting everything as possible from the developer, and making everybody happy. The goal here is that together, the platform team and the infra team, obviously together, because the platform team needs the experts, and the infra experts need the platform team in order to make it easy to consume, will govern the platform. They will take care about managing the capacity, managing the architecture, etc. But they will try to put the user on rails. Again, the goal is to serve our fella from the dev team, trying to make him annoy us as less as possible. But at the same time, obviously serve him, right? We need to provide, we need to fulfill the needs. So how this could look like after a bit of rearranging, right? Like something like this. Again, the same thing as before. I want to deploy my app. Okay, you can use now our cloud platform. Alice got in the middle, trying to help a bit. Let's see what happens. He's talking obviously to Bob, the infra guy. Hey, I want to use any of your APIs to provision this dev environment, and this is the key here. Sure, go for it. This is already in place. And now I'm going to show you a little example about this. Let me go to my laptop. Thank you, Matt. Okay, so. if I go back to workflows, hopefully, I mean, you remember this? Now we have an ACI tenant. We are deploying another cluster, but I already have one ACI tenant. Let's imagine that either Platform Alice, Carlos the Dev, or even Bob, maybe he's trying to play with Kubernetes, why not? They just say, okay, that tenant is there, this is a demo, let me play with that. I want to deploy another cluster for myself in that tenant. I don't want to use this is for Matt and Pedro's demo, don't touch it. So we can have, and I have it here, maybe you saw it before, another item, another workflow, which is called, literally, deploy an on-prem cluster on an existing tenant. So let's try to run this and see what happens. In this case, I mean, remember before was like the name of the tenant, the name of the on-prem cluster, the name of the Google cluster. This is even simple. It's like only add or delete. This is something you could like to find when you're going to consume this, I think. So let's see what happened now. We are executing this, and if we give workflows a moment, this is interesting. We are getting the information of the available ACI tenants, and now we are requested for an action. And literally the workflow, if you see here the yellow box, action required, the workflow is waiting until we come back. And now we have another little UI, which is asking us, okay, you want to deploy a cluster? We need an ACI tenant in this case, in this architecture that we have defined. But we are selecting that tenant from the existing ones. And again, just a reminder, this is coming from here. Under the hood, there is a GitLab pipeline running infrastructure as code, and this generated an artifact that is here. You can see tenants deployed, tenants archive, and here we have tenant Cisco Live. This is an ID. P. Antunes, that's my ID, that's my email. That's the culprit of deploying that today, right? A bit of audition there, audits. So if we go back here, I'm going to choose that tenant, because that was the point. Select, we can see it here. And again, I'm going to call this Berlin demo. Because again, remember, this is on-prem, so this is on Berlin. Now, and only now, because this is a required entry, I can submit. And this is going to keep going in a moment. We are deploying another cluster. And again, if we want, we can go to workflows. There is another piece of infra as code that is deploying this in the background. See, this just was triggered a second ago by me from workflows. And with that, let's go back to the slides. Thank you very much. Okay. Oh, shit. Okay, we have been talking about cloud and multi-cloud for a while. Let's stop for a second here. As you can see, we have timed the slides pretty well, so he doesn't have to quote himself. I do it. That's more elegant. But this is true. I mean, like we have been working together around 3 years in all these topics, and the seed for all of this was basically this: like, hey, the cloud is very easy to consume. The on-prem cloud or the on-prem data center is always a hassle. We only have these stories between people, and they end up going to the cloud because it's easier. But a cloud is only an automated data center. Why cannot we automate it and have the same experience, or at least something closer, right? So let's dig a bit into this concept. What is a cloud? It's literally infrastructure, which is network, compute, storage, something on top, running workloads, virtual machines, Kubernetes, whatnot, and obviously an application. That can be a monolith, microservices, whatever, right? If we go to the public cloud, everything is highly automated, pluggable. Why? Because in the infrastructure layer, we have the same, but we don't see it. It's a service. We don't care. Again, the higher you are, the less you care about the bottom, right? Everything is managed. We do have VMs. We do have Kubernetes, but it's a service. It's managed. It's abstracted. And normally what we deploy here is cloud-native apps, because that's the point. If we go back to home, to on-prem, we have the same, hopefully Cisco, but not necessarily. But this is us, we need to manage, right? We need to manage it, right? On top, we're gonna have VMs and Kubernetes, but again, self-managed, which can be less or more difficult. And normally, we will have more monoliths than on the cloud, historically, right? Everything here is, most of the things here are artisanal, there is high friction, remember the conversation before. And as Matt did in Berlin, we need to rack, stack, and manage everything ourselves. Again, what are we trying to integrate here? It's basically this model of, hey, we have a service, we have a portal, we have an API to the end customer, that's workflows there on top, talking to our systems. At the end of the day, workflows is just doing API calls, right? Every system we have down the road is gonna have an API in some sort, so we can leverage that with workflows. Workflows A is gonna talk to the network, for example, remember configure ACI, that's what's happening. Workflow B, deploying VMs and Kubernetes, I just did it. Workflow C, security, and this is expandable, obviously, that's the point. And this allows us to, like, the further you go up, the less you care about the cloud, about the location. The location is not gonna be based on technicality, it's gonna be based in business logic. I deploy on-prem because this application has sensitive data, not because it's easier or harder, etc. And we can decouple everything, or bundling, depending on the needs. But in general, we think it's a better idea. I mean, workflows can talk directly with APIs, and that's useful. But it's way more powerful if we put infra as code in the middle. That's why what we are triggering is GitLab pipelines in this case. Again, it could be any CI/CD tool. GitLab is just an example. So what is happening here is like we have our source control system. For us, it's GitLab today. Could be GitHub, could be whatever. CI system, GitLab is comfortable for us because everything is together. It could be GitHub Actions, it could be Jenkins, you name it. And expanding the example before, each of those repositories is an infra as code, is a module, is a service in itself, is being triggered, run by these pipelines, and is mapped. This is the same mapping I showed you a moment ago, integrating infra as code. Like workflow A is relying on pipeline A that is running code, repo A, Terraform, Ansible, Python, whatever is better, and doing network, compute, security. And now, let me go 1 second to show you this in GitLab, because this is the map from before, remember? And again, each step here is a project, a repository with the necessary code and associated pipeline, ping with a tag, because if you don't ping a tag, we will modify something and it won't work in a live demo like this, right? Which is not something good. Yeah, change, please. So for example, let me show you, if we go to, we have this folder, this group for Cisco Live. For example, this is a quite simple example to deploy a cluster in Google. It's exactly the same we did a moment ago for on-prem, but in Google Cloud. And I think this is, I mean, we have here our pipeline definition, which is just a set of jobs, some Terraform, and the CI definitions. This is being triggered through the API from workflows. And here we have our history of pipelines. Some are green, some are red. And this is the one I just triggered a moment ago. We can go here. Obviously, we have emojis in the jobs. Why not? And this is a typical infrastructure as code flow, right? Like I'm printing my bus, I am validating, Terraform plan, Terraform deploying, happening now, and then we will push the kubeconfig to another place to have it as an artifact. That's pretty much it. Let's go back. This allows us to have a sort of software bill of materials. This is what we can offer. That way we can talk to Alice, the platform engineer, to InfraBob, to Deb Carlo. Hey, this is what we have. What are we missing? What needs updates, etc. And basically, one key point is like coming from here, like amorphous combination of manual scripts that you need to know the person that wrote that down, or yourself in the past maybe, and know the order, know the environment in order to automate stuff, to an organized, to an organized tool set of modules that are clear, simple, only do one thing, and are pluggable into each other. Again, Lego blocks. And I already talked a lot about infra code. Matt is going to expand on that.
Okay, thank you, Pedro. So Pedro has shown you the demo, what we're running, and we want to talk a bit about, we're not going to deep dive into infrastructure as code, Ansible, Terraform, but more about the principles we want to follow here. So we want everything as code. I mean, this isn't going to happen tomorrow or next week, but the goal should be to define every single step in the process as code. And I don't think that is unachievable. We've achieved it in our data center. I mean, obviously it's a lab environment. In real life, we have silos. Maybe we have organizational politics. It's not always so straightforward, but the goal should be to have everything as code. We want to standardize the data center cloud setups, so provide this module-based architecture with a clear process and the ability to run this on top. We want to provide self-service, so we can provide maybe a service catalog on top of workflows, maybe ServiceNow, and we can order the services from here. We want observability, what is deployed and where is it deployed, and also integrated connectivity and security. And we want that all modularized, and we want that all defined in Git. So what is infrastructure as code? Very, very brief. It's operating infrastructure through machine-readable configurations, YAML, JSON, HashiCorp configuration language, maybe as some you know of. And we want to integrate software best practices. So version control, tagging, testing, I hope, continuous integration, continuous delivery. So we can build new features. I can publish them in version 1.2. Pedro can then consume that, and he can go on living his life knowing that I've done the correct testing, integration testing, unit testing, system testing, to make sure that his modules will still work. And rollback and reconciliation, right? So if someone did an undesired configuration, or maybe someone did a manual configuration on the device, we can override that, right? I mean, this is the typical security concern in the public sector. We want to override configurations made by a potential malicious actor. So a typical example, right? I mean, I'm living in Berlin, so clearly a bit of a hipster. Go down to my local coffee shop, and they say, I say, I want a flat white, and they say, do you want oat milk or do you want cow milk? I say, I normally order normal milk, and they say, well, we don't have that. Anyway, I order it, they serve me the coffee, and it's an easy transaction, right? They give me an option, I order it, and I get the coffee maybe a couple minutes later. The other way, the imperative way is I need to go up to the counter and say, hey, I need you to grind some beans. I need you to heat some water. I need you to froth some milk, and I need you to put that together in a cup. They need to know that. The barista needs to know how to do that, but I don't need to tell them how to do that. And that should be the model we follow when providing our infrastructure code modules to other teams and other members. We shouldn't need to tell them all the steps that happen in the process. They should just ask for a cluster, ask for a virtual machine, ask for a tenant, and it gets deployed. Key also is having a good emoji concept. I mean, it might sound a bit silly, but there are some genuine reasons why I found this quite useful. You can immediately recognize what state the pipeline's in. If you're making multiple pipelines across domains, you can make sure that every step is being enacted by your teammates. My teammates can come in and see what's happening very easily, and it makes automation a little bit less boring, which I think is also important. And the goal really is then we have something like workflows, and we say, look, I can configure my network tenant, I can configure my virtual machines in Kubernetes, and I can configure my application. And really key to making automation manageable is abstraction. So I want to provide simplified services to my users. If they want a Kubernetes cluster, I don't want to provide them with a list of 100 different variables they need to fill out. Let's work with them to find out which ones the key variables are and what we can leave as defaults and define ourselves as the experts. And standardization, right? So we need to create blueprints, templates. We need to create small, medium, large, and get away from everyone having their own Snowflake configuration and having this kind of operational drift. Typical do's and don'ts. Don't let your user go into the kitchen and tell your chef what ingredients to use. Do provide a waiter and a menu with clear options. And don't try and make your organization the burger, pizza, kebab, pasta place, because no one really trusts this place. So do a few things and do them well. So we're going to go back into the demo in a moment, and we're going to bring our cloud environments together with Cilium. Cilium is the de facto SDN for Kubernetes. So this is basically the networking and security tool for the cloud-native world. What we can do here is basically build a cloud-agnostic networking and security layer across Kubernetes environments, and we can bridge these together. And also, you've probably seen things like Hypershield and other tooling. We can also expand into virtual machine estates and potentially network switches, and anything running Linux in the future could be running this. So Cilium is an open source project. It's owned by the CNCF, which is like the Linux Foundation for Kubernetes. It uses something called eBPF. Maybe search eBPF into the kernel, or there's a really great YouTube documentary, about 30 minutes, explaining what it is. iSolvent are the company behind Cilium and eBPF, and they provide the enterprise distribution. So support, some additional functionality that's very critical for running kind of workloads at scale in more complex environments. And Cisco purchased iSolvent, maybe some of you saw it in the news last year. So in our traditional world, we have lots of requirements: IP allocation, connectivities, network security, encryption management, and we have various different tooling that can do this, right? Whether it's a DHCP server, switch, router, firewall, load balancer. Cilium aims to be, and I would say does very successfully, all of these jobs within Kubernetes. So you might have heard that things like Metal LB, kubeproxy. Basically, Cilium said, look, you don't need those. We can do those all for you. So it's a bit of a consolidation of the tool chain in Kubernetes. So what Cilium can also do very well is bridge our Kubernetes clusters. So we can connect our clusters together with a mesh. We could have our application on top here, our Cisco shop. We could load balance or failover traffic to the application. And we can do that across Cisco, data center, Google, cloud, or Amazon, or any of the hyperscalers can support Cilium. And then we can do something like this, right? We have our cluster on the left, we have our cluster on the right, we can do load balancing and service discovery, we can do network policy, basically firewalling, micro-segmentation, we can do encryption between locations or even inside locations, and we can do routing. So with that, I'd like to show you a demo.
Yes, me. You're two.
Okay. Okay, so first of all, what I want to show you is a bit of a catch-up as to where we are. It's just taking a moment to load, which is quite good because I'm logging in to the services in the background. So let's just catch up on what's actually deployed at the moment. So we've run Pedro's end-to-end workflow. This did kick in a bit after a minute earlier. Let's see what happens.
Let's go to my box.
Okay, let's go to Pedro's one. Okay, so Pedro's got the APIC here. We can go into the APIC. We can see that we've got a tenant deployed. That tenant is called TN Cisco Live. We can also view this tenant in the object browser, and we can also see that this tenant was deployed by Terraform. So that was deployed by our ACI's code pipeline. We have also got vCenter. We can go into TN Cisco Live, and we can see we deployed 2 clusters here. So this is not an advertisement for vCenter or VMware. We just need VM capability. Could do this with Nutanix, could do this with KubeVirt. But we have our VMs deployed, Berlin demo, and Berlin. So what we then have is our cluster in Google, and we have this one here, Google demo. So we pre-deployed this earlier, and what we're going to do is create a mesh between these. So we go to cluster mesh, which is probably easier if I search for this. We go to Cisco Live Cluster Mesh. And what we're going to do here is we're going to run a pipeline providing the names of the clusters that we've deployed. So everything we're doing in workflows, we can also do here in the GUI. We could also do it from our laptop. We could also do it with a merge request or a commit, depending on what rules we want to set. So here I'll describe Google/demo, Google-demo, and in here I'll write Berlin-demo. We can also provide some options, right? So we can basically provide an API for our users. We could offer Cilium CLI or Helm install, and we could do a cleanup or deploy. So we're not going to clean up, we're going to deploy. And then what's going to happen is our cluster is going to deploy for us. So what we have then, that's going to take a couple of minutes. So basically what's happening is it's going to grab the information about the first cluster in Berlin, it's going to grab the information about the second cluster in Google, and it's going to create what's called a mesh between them. So first of all, we need to exchange certificates, because this is also based on trust. We need to make sure that we're not just meshing with anyone. And then we're going to do what's called enable cluster, which is basically a GitLab pipeline, which is running a Linux operating system container, could be a VM as well, and this is executing a series of commands that we've defined. So this is basically an imperative set of actions, and we're abstracting that into a declarative way. So what I would like to show quickly is a cluster that we deployed earlier. So Pedro, could you type 34.90.156.145? And here we have one that we deployed earlier, and we can see this in Hubble, which is the Cilium observability tool. And it's a little bit small, but you might just be able to make out it says Berlin and Google. We've also got here our shop. We can go in and refresh that, and there we see it's going between Google Cloud and on-premises. And the really nice thing about Hubble is we can basically see this traffic flow here. So we can choose our namespace, we choose the Cisco boutique, we zoom right in, and then we can see, for example, we have this application, and we have some of the traffic here going to our Google front end, and this is all, because it's connected with Berlin, we also have traffic flows in Berlin. So we have this highly available distributed application with a load balancer in front, and the load balancer says, I'm just going to do 50-50. Half the traffic goes here, half the traffic goes there. Also pretty good for like A/B testing, red-blue testing, right? Or red-green testing. We can change the level of load balancing slowly over time. So we could up this to 60%, 70%, 80%, 99%. And then basically once we're sure everyone has moved over to the new application, we can shut the old one down and take that offline. What we can also do is we can define policies. So I have a cart service. So I have my shopping cart in my application. I put the Cilium ebook in here. But this also needs to speak with a database, which is in Redis. So if I zoom in here a bit, you might be able to see some of this. So we have our cart service talking to our Redis cart. And what I say is, look, I want to have a new firewall policy here. So what we can do with Hubble is we can generate infrastructure as code configuration dynamically. And this is being done based upon flows that are being detected in the network. So our developer doesn't know what firewall ports he needs. Okay, we can find out. We don't need to go through the dance, back and forth. What firewall ports do you need? I don't know. Okay, let's enable them one by one until you finally get your application up and running. We can say no. Deploy it in a test environment, find out what ports you need. We can define those and create policy for these. And for example, I can add a rule to this policy which says the car service is only allowed to talk to the Redis service on port 6379. So I can define my firewall policy as code. I can save that output. I can put that back into GitLab, and I can run a pipeline to deploy it, or I can deploy it directly onto my Kubernetes cluster. Okay. So we've done the cluster mesh demo. We've shown the app in Hubble, and we've shown the traffic. So we're at Cisco Live, and this is a request we've had a lot in our sessions, and I apologize to anyone who came to our previous sessions and didn't get this. We put a lot of work in the past couple of days trying to define what's happening on the networking layer, because this is probably of most interest to everyone here. On the left, we have a Kubernetes tenant in ACI. We have Kubernetes nodes as VMs. These could be bare metal servers. In the end, we deploy what's called a tenant, which is a construct in ACI to provide logical separation. We deploy our virtual machines in here. We have a gateway in ACI, which is where we send all our traffic to. So a default all zeros route says the traffic goes to the gateway. We then have a physical router, an ASR 1002X, which is probably end of life by now, but it's a lab, and it works. So we have BGP peering between these two environments. We have an underlay network, which is basically connecting to the internet. So Google will expose an internet-based IP address, and then we are sending traffic to that IP address over the classic internet. But what's happening in SD-WAN, we actually have a peering with this on BGP. This creates an IPsec tunnel with here, and then forwards the traffic over the VPN. So our Kubernetes nodes won't actually know they're going over the internet. They'll think they're going over a private network, then all the traffic will be encrypted in the VPN. So what do we need for cluster mesh? I mean, it's quite simple. Can the nodes ping each other? I mean, we could probably even remove ICMP and just allow the specific ports for cluster mesh, but this is a pretty good barometer. If they can reach each other, yes, we can then establish a mesh. And then once the mesh is established, then we can build a cluster mesh. So we build a tunnel between the clusters. And this is where things start to get a bit confusing potentially. We have ACI running VXLAN, which is an encryption, also overlay technology. We have SD-WAN, which is running an overlay on top of our underlay in the internet. And we have an overlay inside Kubernetes on top of our overlay in SD-WAN and ACI. Yeah, you can see why troubleshooting gets a bit complex, right? Anyway, it works, but we need a lot of expertise and a lot of teams to bring this together. But the great thing is it's a one-time, or hopefully one-time task. Once you've done this and automated this, you can repeat this model again and again, and you can be sure that your connectivity is going to work on all your future deployments. So the app deployment, what we do is we deploy the same app in both locations. This is it's called the Google Microservice application. You can get it from github.com. It's open source, freely available. We deploy the front end, the back end, the databases on both sides. We then deploy what's called a gateway. The gateway then will basically load balance the traffic to our various front ends. And Google will be so kind to provide us with a public IP address. So that's how we can reach our shop. Also, Kubernetes networking constructs might be a bit confusing. I highly recommend go talk to the iSolvent guys. Get your hands on a copy of the ebook, or the book, the physical book now, and see, you know, there's got a lot of good content in there. You can also download the ebook online for free. I believe you just need to give your email, and maybe they'll send you a couple of marketing things, but it's definitely worth getting. So, we're into the last 5 minutes. So, what are the conclusions? We wanted to show everything is as code. Maybe we've got a little bit of time at the end, we can dive in if there's a couple more questions. Standardization, self-service, observability, and integrated connectivity and security. So hopefully we showed this to you today. We are in a consulting team, so in the end, we're not selling a product, but what we are selling is ourselves, our time, our services. If any of you are using any of these technologies on here, we have automation modules that we've built. We have automation modules, some of them are open source, some of them are internal, but we maybe look to publish in the future, that we can provide to you with a jumpstart. Or if you just want some consulting on how to build these kind of architectures or integrate modern technologies, we're very happy to help. So, Pedro, what are your conclusions and takeaways?
Yeah, basically, I'm gonna go back to this conversation between our friends before. And I mean, as you can imagine, this is complicated at the beginning. It's gonna be a lot of back and forth. It's impossible to design something having it landing perfectly from the very beginning. So our recommendation would be what you see there, like identify one or two use cases, not too ambitious, but representative of of the needs of your organization, your developers, your internal customers, etc. Try to make all of them happy, you know, following an 80-20 approach, because it's really difficult to make everybody happy, but we need to strive for some kind of trade-off here. And again, it doesn't have to be perfect. You need to iterate and try to break down silos. Try to bring people together. And the key is here. I mean, I want to go on holiday knowing that Matt can deploy a cluster without calling me. I mean, annoying me or waiting 1 week till I came back from Spain. So that's basically the goal. And if you click Matt, we have a very good summary of all of this here. Like, that's going to happen. Just iterate and pave the user experience road and reassess and keep going.
Yeah, and I think the key takeaway for me here is really, we're going to build our low-level infrastructure as code configurations. We're going to write Terraform scripts, Ansible scripts. We're going to have the ability to configure everything in our infrastructure. But our user, maybe the compute team or the server team or the application team, they don't need that, and they don't necessarily want that. So let's work with them. Let's start very small, and let's increase the options as we see these paths emerge. There's some great links here. The ebook, like I said, is available here. The labs for iSolve and Cilium, all online, all free. The eBPF documentary I mentioned on YouTube is here. Normally, tech documentaries can be a bit cringe. This is very well produced and very funny. We also have some links to the open source code that we've provided here, and also an ACI Cilium BGP design guide, if any of you are looking to do Cilium on-premise. And we've also uploaded the Google Cloud microservice with the Cisco flavor. So if any of you want to deploy our store with our WebEx classes and our ebook, here's the way to do it. And the slides will be provided to you after the session in the app. You download the PDF. Of course, download the app, join the space. Any questions, please feel free to reach out to us. Anything we've missed, we can provide you with some more context. And yeah, if you enjoyed the session, please fill out your session surveys. And thank you very much for your time. We've got some time for questions, or come up and talk to us. Right, our pleasure. Thank you.
Yep. Thank you very much.